Hi everybody, welcome to Video Notes Unit 2A and 2B. The story of particles that make up matter begins. Well, it already began. We're just digging deeper. So here's the main objective, all right? And here's what you should be able to do with that. Okay, here's the other main objective, and here's the bullet points that relate to it. So I'm not going to read them to you because I know you can read, but I am going to do some explaining. Okay, so states of matter. If you had to label these, I know you would be able to. You would call this solid, liquid, and gas. Okay, so make sure you can visualize those molecules, right? Now, we can't see them, but if we had to draw them, this might be what they look like. Okay. So here's a little bit more of a description of each of those. Now, we're assuming this is all the same substance. So all of these particles are the same kind of particles. Those are the same kind of particles. Those are, for instance, H2O, 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 or copper, copper, copper. All right. So you can see that if you increase the energy of these particles, they will change their states. All right. But we also said they were moving. So I'm going to put whooshies. All right. So these are moving, but they're only moving a little bit and they're kind of vibrating in place. But remember, constant motion, constant motion. Okay. Liquid. Once they're liquid, they have more energy. In order to change from a solid to liquid, they have to have more energy. So we got a little more whooshies, like whooshies. Hey, we're moving. Now, I know you guys like to use arrows for movement. So we would have really short arrows, and then they bounce and vibrate in place. Here, they have enough energy to move around each other, and that's why liquids can flow. Solids can't flow because even though their particles are moving, they kind of just go back and forth and up and down and maybe spin in place. These have transitional and rotational and vibrational motions. So they can move around each other. They can move back and forth, and they can rotate as well. Okay, gases, we're going to put 3 whooshies on them because they are moving. What caused them to be able to move this much? Increasing their energy. Okay, so the more energy it has, the more motion it has. Okay, so look at all those whooshies. All right, so make sure to read this. Put in your notes something about each of them. This is beyond what we're going to do in class, but it's also pretty cool. Okay, what happens to a particle when energy transfers in? So we look at things as systems, all right? So say we have a system. All right, let me look back. Like, here's a system, right? So where does the energy have to come from? It has to come from outside, right? But whatever comes in is the energy that's causing something, okay? So whatever comes in, transferred in, is going to cause them. So particles would gain energy if it transfers in. All right, particles, all right, so I'll put they. What happens to particles? They gain energy. Okay, when they gain energy, they move more. Okay, all right, they move more. And we're going to assume they just stay. They might be more energetic solid or more energetic liquid or more energetic gas. Eventually, they could also change from a solid to liquid or to a gas. Okay. Now, what happens to particles when energy transfers out? The particles, they lose energy. Okay, that's the energy that transfers out of the container or out of them. They're going to move slower. Okay, maybe vibrate less or rotate less. Vibrate less, rotate less. All right. So that's what would happen. So I want to put a note on this slide. I could have put it on the last slide. What is energy, might be wondering. So we're going to consider energy a conserved substance like conserved. Ooh, that's an R. Conserved substance like. Substance like. So it's not really matter, but it's conserved in a substance-like way that comes from somewhere to somewhere. So that causes change. Substance-like quantity that causes change. That causes change. Sorry, it's a little messy, but I'm not doing it. change causes change. Right? Oh my, who wrote that? Anyway, okay. So energy comes from somewhere and goes to somewhere. It's conserved though, so you should be able to account for all of it, right? So we're gonna talk about the kind of energy we're talking about here is the energy of motion. So we'll call it ETH, and it's going to be energy stored thermally, thermally in the motion of particles. Okay, so what does that mean? Okay, so what happens to particles when energy transfers in? Well, the thermal energy, the energy stored in the motion of the particles, gets lost when, I said in, but when it transfers out. So they lose some of their ETH, or their stored energy. So then they move slower, or vibrate less, or rotate less. Okay, so what's one way to keep track of this transfer of energy? Okay, temperature. So temperature is going to be considered, we're going to call temperature the measure of stored energy in the motion of particles. So that's like the ETH, right? The ETH. All right. Again, I'll write it. Hopefully I'll write it down too. ETH, energy stored thermally. Energy stored thermally because of motion in the motion of particles. All right. Who are these guys? All right. Anyway, so what do we use to determine this energy stored thermally in the motion of particles? We use the thermometer. Okay, and the energy, you add thermal energy and the molecules move more. Right? So if you have a cool liquid, molecules are moving. But you add energy to that liquid, the molecules get hotter, and so they expand. Right? So here's short whooshies, here's long whooshies. This has more thermal energy. Okay, so if this hits the thermometer, then the molecules will transfer their energy into the liquid. It's either mercury or an alcohol usually in there, and then that will expand and move up. All right. If these aren't moving as fast, then sometimes the energy from these will transfer out to there, and then the energy that's transferring in is not as much, and so it doesn't push the liquid up. It doesn't expand. Okay. So air molecules move slower in cold air, so then the mercury does not rise. Okay, it might lower if they're going slower than the molecules in the mercury. If it's warm, the molecules move rapidly in causing the mercury to go up. Okay, so it's about transferring their thermal energy, all right, their thermal energy into there, and that moves up, all right. And this is maybe transferring the thermal energy out, and so it moves down, okay, or just a little bit of their thermal energy, and this is a lot of thermal energy. Okay, so talking about molecular motion, we got to talk about kinetic molecular theory. So as it applies to gases. Okay. So kinetic means moving. Molecular means molecules. So the theory of moving molecules. So particles of a gas. So make sure you know these points. We already told this in our story when we did about the smelly particles. Okay. So and then, so the gas particles are in constant random motion, moving in straight lines till they collide with the particle or wall of a container. They experience elastic collisions. They don't eventually run down. They just hit and bounce back, not lose their energy, not slow down. Okay, they just bounce back. Right? That's what an elastic collision, and they don't stick to other particles. It's our theory. So their speed relates to their temperature. Right? Pressure relates to how often particles collide with the sides of the container. Okay? So, what happens to collisions of particles if more particles are added to a container? All right? So, let's look at a picture. So, if more particles, what's going to happen to collisions? Well, more particles means, so here's 4 particles, they're going to collide with each other on the wall, but then we get more particles, there's going to be more collisions. So, more particles means more collisions. More collisions. All right. More particles, more collisions. So That means higher pressure because pressure is the collisions. What happens if the particles in the container move faster? Okay, this is a random H. Random. Don't know why it's there. Okay, so here's particles. This is a cooler gas. Notice how the arrows are kind of short, right? So they're going to hit and bounce around. These are hotter gases, so they hit and they bounce farther, okay? So there's going to be more collisions because they're moving faster, okay? More particles, more collisions. More particles, more collisions. What happens if the particles in the container move faster? So what makes them move faster is they got some energy, right? More move faster, more collisions. All right, finally, whoa, who wrote that? Collisions. What happens if the size of the container gets bigger? Okay, so we have all this gas trapped in this side of the container, but we open this up, and now the gas can go on both sides. So what's that going to do? Okay, that's going to be less collisions. Why? Because there's more space. They're not going to run into each other as much. They're not going to hit the walls as much because here they're going to hit the walls more often because there's a little bit of wall space and a lot of molecules. Here they're going to hit the walls less often because there's still the same number of molecules, but they're not going to be able to hit the wall as often because there's more places to go. Okay. So to review, molecules in motion make up matter. That's very alliterative. Matter can exist in solid, liquid, or gas state. More particles move, the more space they take up, and at a certain point they can change state. The kinetic molecular theory describes gas particle motion. Energy gains or losses causes molecules to speed up or slow down. A thermometer liquid moves based on the energy transferred into or out of it by surrounding molecules. And then make sure you can use particle diagrams to tell the story of states of matter and moving molecules and to explain stuff. Okay, so just the kind of stuff you'll have to be able to explain. Read this, see if you know a little bit more now, and then come up with questions you want to ask or things you want to talk about. All right, hope you took good notes. Peace out.